Hello, this is Chris Moberg, bringing you another quantum video training. In this training video, we'll be discussing doing runs with load. This is only applicable to dynos that have eddy brakes, and in particular, we will look at static load and interpolated load. You access load when setting up the run. After you choose the type of run, in this case we'll do gear roll on, and this brings you to the load setting if you have an eddy brake. In this case we've got static selected and 50% load. And through the magic of video instruction, I'm going to cancel here but have the completed run available to me. So this was a Cummins truck, more than capable of pulling against that load, and made these particular numbers. But what we want to look at is our commanded force, and we can look at our delivered torque. So down at the 50% line, we see that commanded duty cycle was 50% from beginning to end of the pull. And up at the top, we see that our resultant torque was 288 foot-pounds at the beginning of the pull, dropping to a little less than 250 at the end. Let me do a sidebar here to say that this is fairly typical performance of an eddy brake, that at lower speed and when it's cooler, it is making its maximum force. As it heats up, as the RPM increases, it falls off somewhat. And we can learn a few other things. You'll notice that I have speed rather than RPM on the bottom axis. And the purpose of this is so I can see at what speed the run is starting. We're really triggering the run based on RPM, but I want to see the corresponding speed, and you'll see why in a moment. So I'll turn this graph off. So at this point I'm going to do a new run, gear roll on again. I'm going to do interpolated, and I'm going to choose a minimum. Well, first I'm going to interpolate over speed, and then I'm going to choose a minimum speed, and I'm going to choose 40 miles an hour. I'm going to go to 90 miles an hour. Now, thinking back to our previous run, we did the tip in at 50 and we went to about 100. So I'm purposefully interpolating over a somewhat offset range. On the front end of it, it's important to start the interpolation before the tip-in point on the run, as the eddy brake doesn't turn on instantaneously. So by starting it at an earlier miles per hour, we allow it to come up to force before the run start. And so it's a bit of a guess at what slope we want here to have the real target load at the point we want it. But I'm going to put in about 45% at 40 miles an hour. Our previous run went up to 100, but I'm stopping at 90, and so I'll put in about 65 here. And so now I've got 40. It'll come on 10 miles an hour before my expected start. It'll be fully up to force when that truck hits it with that heavy torque load. And by 90 miles an hour, we'll be at our max, and so we'll hold our max through the end of the pull. Okay, once again, through the magic of video instruction, we can go here and we can look at how that panned out. So you can see now linear interpolation. The load is commanded from well, looks like about 47-ish to 65 from 40 miles an hour to 90 miles an hour. And so now if we superimpose on that, on this axis, we do primary torque PAU, we see that we get a rough approximation. It has sort of some more curvature to it than our linear command. Application of torque. It goes from 275 to 325. And so the idea here is when the truck was starting, we wanted to have less force, less torque resisting it. And once it got rolling, we wanted to give it more force. So that is how you should set up your interpolated runs. You really need to do sort of a static load or an inertia pull before you set the interpolated run up, so you can get the all-important range in mile per hour of the pull. And then armed with this, you do an offset, as I did, to get the eddy brake up to speed before the interpolation really gets going over the course of the pull. So that's it for this instruction.